Good morning everybody. Today we will discuss the structure of the XeO2F2. We know the ground state electronic configuration of the xenon is 5s2, 5p6, 5d0. In order to form the 4 sigma bond with fluorine and oxygen, 2 of the electron in the p orbital, 3 of the electron in the p orbital is excited into the d orbital, and we have 5s2, 5p3, then 5d3. Now the 1 of the s orbital and 3p orbital and 1d orbital undergo the hybridization, and we will have sp3 hybridization, and the 2 of the d orbital does not involved in the hybridization. So these hybrid orbitals are arranged in trigonal bipyramidal fashion, in which the one of the lone pair of electron exists in the hybrid orbital, and this hybrid orbital placed in the equatorial position in order to avoid the lone pair bond pair repulsion. And 2 of the sp3 hybrid orbital form the sigma bond with the fluorine atom. They are arranged axially, and the remaining 2 of the sp3 hybrid orbital form the sigma bond with oxygen, and the 2 vacant orbital d orbital, which does not involve in the hybridization, form the sidewise overlapping with the p orbital of the oxygen and to form the multiple bond pi bonds. So the actual structure of the XeO2F2, if you are avoiding the lone pair of electron, is seesaw structure. Now we have to discuss the structure of the XeO2F4. As we discussed earlier, the xenon form an octahedral structures in which oxygen atom occupy the trans position to the octahedral geometry. And see here, the hybridization in XeO2F4 is sp3d2 hybridization. We have discussed the sp3d2 hybridization before. Now we have to discuss the structure of the XeO3F2. The XeO3F2 also follow sp3d hybridization, and they are arranged in trigonal bipyramidal structure. Now, why the xenon form these many compounds? So xenon atom, while we are comparing the other elements of the noble gas, has largest size, and the xenon has the largest ionization energy, so it can form easily the sigma bond with the electronegative atom like fluorine, oxygen, and the fluorine and oxygen can able to shift their electron to the vacant d orbital of the xenon. That's why the xenon form the compounds with fluorine and oxygen. Now we have to discuss the fluoride of the xenon compound with water. What are the reaction between the xenon fluoride with water? We have already studied the 3 different type of the fluorides of the xenon: XeOF2, XeOF4, and XeF4, X6. XeF2, XeF4, and XeF6. XeF2 react with water and to form Xe plus 4HF and oxygen. Similarly, XeF4 react with water and to form the elemental xenon and XeO3 and HF and and oxygen. Similarly, XeF6 react with water and to form XeO3 plus HF. These are the reaction between the xenon fluoride and water. Sometimes the XeO4 may react with water and to form XeOF2 and HF. Similarly, the Fe-F6 also react with water and to form XeOF4 and HF. Thank you.